morning. It's really early here in the UK and the rest of the house is asleep, so I'm going to try not to wake them up. So today we're going to build a Frequency Central Routemaster power bus. This is the Frequency Central website. So if you're interested in the PCB, can't spell, Routemaster, type in Routemaster there. Really great website, just comes up and you can see there that it's £15 and it says Routemaster is a simple to build combined power supply and bus board. It can be powered from a 12 VAC wall wart or alternatively a 12 VAC centre tap transformer. So it's an AC transformer that you need, not an AC-DC transformer, and that's a really easy mistake to make. AC transformers are not quite as common, but they can be bought in the UK and they're probably more common in the rest of the world. Options are included for Euro, MOTM or .com power headers. The supply is adjustable for plus or minus 12 volt DC or plus or minus 15 volt DC using multi-turn trimmers. There is an onboard 5 volt DC supply too, so it works with your digital modules. I can't say that word. It's a cracking little power supply. I've used them a lot. It says that it's rated at he suggests 1 amp. So he suggests a 1 amp wall wart. And that will output 500 milliamps on each power rail. So there we go. They used to be red, and all the other ones I've got are red, and the one that's arrived is green. But we'll look at that and explain why in a minute. So if I go to the build document, as usual, great instructions. Can't say the word. And in the bill of materials, the BOM, if you click something, it'll take you to the relevant website. And this is tader.com, which is quite reasonably priced components. I have costed this and I've priced it all up. Everything, including the wall wart, so an AC transformer, all the parts, the PCB and the shipping in the UK, it comes to about £50. So the total price for a build is £50. Now, it would be cheaper. Obviously, what I did to price that is I put like 2 of these in my shopping cart. And the reality is they're quite common components that you'd use in other things. So you never order 2, you'd order 30, 40, whatever. So if you do bulk ordering, the price comes down. Most of the cost is the shipping. So the components from Tader only came to $6.86, but the shipping came to $7.06. So the shipping was more expensive than all the components. There was a couple of components I couldn't get on Tader. One component I couldn't get on Tader, and that were the power headers. They don't seem to have them at all. So 16-pin IDC power headers. I got those from Switch Electronics in the UK. And again, they're very cheap. Buy loads of them, and then you're laughing. You've got them for any other builds. One of the other reasons I really like Frequency Central's builds is a lot of the components are common across a lot of the PCBs. So it's the same kind of resistors, similar values, similar transistors, similar op amps, and so on. So you can buy more than you need, and then you've got kind of stock. I haven't actually had to buy any components for this because I had everything in stock, ready to do the build. So that's it. So there we go. So we've got the build document up. It's useful to have the build document up if you're building something. And it says install and solder all resistors, install and solder all 1N4004 diodes, install and solder capacitors, and so on. So it's pretty straightforward. It kind of tells us what we need. I will leave that up for my own benefit so I can kind of use it. And again, this is a low production value, fairly rubbish video. With lots of rambling in real time, because why shorten a video? Why shorten the video? Let's make it stupidly long for no apparent reason, because you've got better things to do with your day. There is a reason why I quite like the long videos, because when I watch YouTube, I quite like a long video. That's because I use it at night and go to sleep to it. Or listen to it in the car, stuff like that. So I quite like a long video. I don't mind. And the thing about this video is it'll be mostly a load of rubbish, talking a load of rubbish for no apparent reason. About anything really. Life, the universe, everything. In the previous video, I kind of showed you what you needed to do stuff. So I'm not going to go back over that. So I've got things like my blue tack and my flux pen, and bits of tape and all that kind of stuff. I forgot to mention these though. I do use these because my eyesight is failing. I'm 52 years old and I can't see things. So I do use a bit of magnification from time to time, which is helpful. So we'll turn this up. We'll go to 380 degrees on the soldering iron. We'll give that a clean in a minute. Doobie-doo. And the first thing we need is the resistors. Which ones should we have? The first ones on the bottom are the 220 ohm. So 220R. So the R is just ohm, not kilo ohm, just ohm. So 220 ohm. 220 ohm resistors. And in the last video, again, I showed kind of matching resistors. Do you need to? They're 1%, they're quarter watt, 1% metal film resistors. You probably don't need to do this, but as we said, it's just it's a thing I do now. So that's coming out at 219. What are we after? 220. That's coming out at 219. We only need two, so those two are perfect. We'll have them. So we'll take those two resistors, work out where they go on the board. I have no idea. I haven't built one of these for a while. I have built, how many of these have I built? I've built 4 of these in the past. And I really like them. My suitcase build, if you've seen that video, uses 3 of the Routemaster, 3 of the Routemaster PCBs, 3 of these, and they're connected together in parallel. Well, they were, and then I changed my mind. So what I found was the wall warts, the plug-in transformers that go in your socket in the wall. I think they lie, and certainly on Modular, Modwiggler, a lot of people comment and say that the output rating of the transformer is not accurate. It's not true. And I think there's some truth in that, because I put 3 PCBs on a 3 amp wall wart and it struggled. It didn't work. It was powering up, everything worked fine. I don't need that. Everything worked absolutely fine. But on powering up, some of the digital modules, in particular clouds, seemed to struggle. They wouldn't just start up straight away, excuse me, and that's because the capacitors filling up with juice, these big capacitors here. So you need to power cycle it, so you need to turn it off and turn it back on again. And I didn't really want that. I wanted it just to go, you know, just to boot up. So what I did in the end is I split one of the boards into a separate power supply. So I put a separate wall wart onto it. And that helped, because then, that's a really bad start. We're going to have a bad day, aren't we? Because then, then I had enough juice. So what I ended up with is about a 1.6 amp transformer on one of the boards, and then a 2 amp transformer on the other 2 boards, or maybe 3 amp actually. Now, Rick says if you load it, if the load is 3 amp, that's really pushing the voltage regulators. Probably a bit too much and a bit too hard. He does say what you need to do is put bigger heat sinks in. So in my other case, I do have bigger heat sinks on the voltage regulators. And you'll see that in a minute, the voltage regulators. Because these boards are really good at dissipating heat, it's quite difficult to get enough heat in to solder them actually. And I asked Rick why they've gone green, because they used to be red, which made sense because Routemaster was a bus in London. The big red buses, the traditional London bus. That's better. So I've upped the temperature to 400 degrees now because it's struggling to heat up the pad. And Rick said that the green PCBs, the new ones, these, have got an additional ground plane. So it's got an additional negative layer on the ground plane, which is also why it's harder to heat up, because with that additional ground plane, it dissipates even more heat, even better. So I guess that's why he's done it. Probably because we're all pushing the PCBs beyond what they should be. So there we go. That's those two. So this really is probably the most cost-effective, reasonable power supply in eurorack. I haven't found anything that is quite as cost-effective. Yeah, sure, you can get passive bus boards for less money. Cat, that's what you're doing. Stop it. I have a cat in here. She's called Tilly. She's a kitten. She may make an appearance. It may be undesired. We'll see. Yeah, sorry. So you can get passive bus boards where you link it to a power supply, something like a Meanwell 65B a lot of people use, which is a AC/DC transformer. The issue with that is by the time you've bought the transformer and the bus boards, you're probably up at around about 80-90 quid for one, if that kind of makes sense, one kind of bus board. Whereas with the frequency central ones, you're about 50 quid, including the transformer. So I think it's more cost effective personally, I think. I'm looking for 1K here. It's just slightly below. I think that one's the same. Just bang on that one. And they're all about the same. So those three are good. We only need 3 of those. These are 1K transformers. Sorry, resistors. Transformers. I've got transformers on the brain now. Transformers. Robots in disguise. So those are my 1K resistors. I need 3 of those. Not doing these in any particular orders today. It's just because it's too early in the morning. I'm half asleep. I don't know what I'm doing. Alternatives to this, if you wanted to look at alternatives, you could look at maybe the Dopefer PSU3, I think is the new one. They do a DIY kit as well, but it probably isn't quite as much enough juice for like 4 bus boards. But if you went for the PSU3, that is actually more powerful than this on one kind of power supply. 1K. It's got 2 1Ks on that side. And in my last video, I showed that I'm putting them in on the same, trying to put them in on the banding the same way around. 1K. And the cat is now jumped up by the soldering iron. It's extremely dangerous for the cat. He's an idiot, and the cat may make an appearance. Because cats and synthesizers, right? Hello, Tilly. What are you doing? Yeah, you're on camera. Yeah, you're famous. It's not particularly helpful though, cat. Take you, yeah. Take you away. There we go. Yeah. Cats and synthesizers. What is it about cats and synthesizers? I don't know. Strange animals, cats. I should probably also mention that the last build was a frequency central PCB and this build is a frequency central PCB. And I probably need to mention that I'm in no way sponsored or provided with any of this stuff by Frequency Central or any other manufacturer. Tader don't provide me with bits. It's all paid for with my own pennies. It's not like an advert or anything like that. There is a reason I'm doing this PCB, when I built the suitcase, I took a power supply. In fact, I took 2 power supplies out of my 2 original cases. My original cases are kind of separate boxes. And then my sister's boyfriend has got an interest in getting started with eurorack and modular. He's got an Arturia key step, I think, and maybe some other bits and bobs, some semi-modular. And he has expressed an interest in getting into eurorack, but of course the cost of the case and stuff is always scary for people, because you kind of go online and you look at the cost of cases and it's just insane. I get why it's expensive, you know. Things are made in limited quantity. You know, this is a niche hobby. Oh, that was the other thing. I've got 10 subscribers to the new channel, and I was chuffed to bits. I didn't expect any at all. So thank you. If you've subscribed, I am really chuffed. My aim is to try and put out a video a week. No more than that, because I'm lazy. And also I have a full-time job and do all that kind of stuff. So apologise, the content isn't like flying out like I'm a pro YouTuber. As you can tell, I'm very not a pro YouTuber. Ooh, I was about to make a horrible mistake. That is a 330 kilo ohm resistor, and we need a 330 ohm resistor. The wrong resistors I have prepared in the box. Bad news. So I'm glad I've caught my mistake, because that would have been bad. And I'm going to have to go and find the right resistors now, which could take me like an hour or something. No, it won't take that long. Let's just go get the box of resistors and see what we've got. So this might stop the build actually, because I might not actually have 330 ohm resistors. That would be bad. Yeah, so my sister's boyfriend, he wants to get into eurorack, and the cost of the case is scary, and of course everything's scary, because you kind of look at all the stuff and you're not kind of sure what you need. That's one of the problems with getting started in modular or eurorack. Is it's a bit of a minefield when you start. You don't need a case. I've seen who was it? Oh, there we go, 330. Got on. Robin Vincent, Molten Music Technology YouTube channel. Really good YouTube channel. Love Robin's videos. Robin built a case out of cardboard at one point. That was really good. I was really impressed. It wasn't so much a case, it was more of a stand, I guess. But it worked. It was fine. So you could build a case out of cardboard. But I think the other side of it is what attracts us to eurorack is the tactile nature of the game. Is the fact that it is an instrument that invites you to play. And I guess if you've got a nice case, something that looks a bit fancy, you're more likely to want to play with it. Maybe, I don't know. Certainly in my case, the aesthetic does matter a little bit. Like, the prettier it is, the more I want to play with it. I don't know why. I don't know why that is, but it seems to be a thing. So you could make a stand out of cardboard. The other expensive bit with getting into eurorack, I say expensive, it's not dirt cheap. The other expensive bit is the rails, the vector rails, or Z rails, or whatever rails you choose. There's a few on the market that are a little bit cheaper now as well. But your rails that you mount the eurorack stuff to, they can be a little bit pricey. So I think in the UK, we pay around about £40 delivered for a set of rails at like 120, sorry, not 120, 104 horizontal position. So everything's measured in HP, horizontal position, which means you've got 104 locations wide that you could put a panel. Now, of course, the reality is that most panels are between 4 and 10 HP wide. So you run out of that real quick, you know. If you've got 104 HP, that's 10 HP modules, isn't it? And then a 4 HP module just to finish off. So that, yeah, it's all space. Space is a consideration. And that's another reason why I quite like frequency central modules, is because they don't generally get silly in their width. They tend to be between 4 and 10 HP, which is quite reasonable. Some of the manufacturers' modules get silly, and they're really, really wide, and they're beautiful modules, don't get me wrong. Complex oscillators, things like that, tend to be a lot wider. And Rick Holt at Frequency Central has recently done the Ox40 filter, and that's quite a big module, but he makes no apologies for it. He's quite happy with it. 1N4004 diodes. 1N400 diodes. We could check a diode. Can we check a diode? There's a few different. I don't know. Can you check a diode? Let's see. Let's have a go at this. I tried this in the last video and it didn't work. This is a very, very cheap component tester. Do it cheap. And it didn't work when I tried it last time. I need 8 of these. I don't know. We've got 1, 2, 3, 4, 5, 6, 7, 8. That's almost all my diodes gone. Oh God. I did try this in the last video and I messed it up because I couldn't remember how to use the little clampy bit to clamp the component. And what I was doing is I was pulling it like that, putting the thing in, and then doing that, and it actually works the other way around, like an idiot. So there we go. Diodes have got a negative and a positive. The negative is the band, I think, as I understand it. So what do I have to do? I have to go in there and then, no, it's the other way around. Go in the hole and then let go. All right. This might not work, of course. This might be the worst bit of TV ever. No. Am I going the wrong way? Do I need to go in there? It's going to be another edit out of this. I edited the other bit out because it was rubbish. Oh, there we go. Hey, diode. Tells you about a diode. Look at that. That's brilliant. Yeah. So diodes don't tend to be rubbish out the bag. They tend to be pretty good, to be fair. So the diodes, I think, yeah, they go down here. So there's 4 of them, and the band is marked on the PCB. So we've got a little line. So you need to make sure they go in the right way. And I believe this may be the rectifier that turns AC current into DC current. Why do I need 8? Oh, there's more. There's more. I can see more. There we go. So, as I say, this is the bit that turns AC current into DC current. And obviously your modules use DC current. And I think this is the bridge rectifier. I think that's what they call them. I don't really understand how it works at all, because it's electricity, as we've mentioned previously. It's electricity. Anyway, yeah, going back to my my sister's partner who'd like to get into eurorack, I thought, well, I don't need those 2 boxes that I've ripped apart now. I'll give him one of the boxes. I'll give him one of the cases, and he can get started in eurorack. That'd be nice. But he'll have to get his own rails, because as we said, they're about 40 quid, and I haven't got 40 quid to throw away, and I needed the rails for the other case. So rather than me buy more rails, I just took the rails as well. So just a thing of note, that diode is one way up, and that diode is the other way up. And I guess we'll find the same there, which we do. Yes, I thought I'll give him that case. And in the process of wiring up power supplies, I accidentally blew up a power supply, which was my own fault. I created a short, and so I had a power supply that was broken, which was the power supply I was going to give to my sister's boyfriend. So this power supply is the replacement for my sister's boyfriend. So he's getting the Gucci one, and I've got the really old ones. I don't know how that's worked out, really. It's bad, isn't it? So there we go. That's all the diodes in, and we'll solder them in place. Just wait for the soldering iron to heat back up. I mentioned this soldering iron before. it runs an open source software, and you know what? It's really good. And it's got a sensor that you put the soldering iron down, and it waits a few minutes, and it starts to cool down to save your tip automatically, which is nice. I think that could do with a bit more solder on there, which is a great feature. And then it will, when you pick the tip, when you pick the hot end back up, it then turns back on, so it's automatic, which is really cool. I have noticed it's not perfect though. It doesn't like work every time. Sometimes you have to manually turn the heat back up. It just doesn't sense, or it goes into sleep mode, I think, is actually what happens. So depending on what you've set it to, and you can set everything, like you can tell it what tip you're using, you can, all sorts of things. I just leave it really. That's ugly. I've made an ugly solder joint. Unhappy about that. Let's see if we can get that flowed a bit better. So this additional ground plane that Rick Holt's put in this board means that you need even more heat or even more time. I think, there we go, that's better. I don't really want to go much hotter than 400 degrees because I don't want to start melting components, which is a thing that you can do. It's all good fun, isn't it? Anyway, I hope you're having beautiful days wherever you are in the world. So in the US, I think that all this shipped, all the components, the wall wart, I guess you're looking at around about $60. Which, do you know what? For a eurorack power supply, it ain't too bad. It's pretty good. And as I say, the other ones in my other case, I'm running it close to, or they have the ability to produce more power because I put bigger heat sinks in. This is not going well today. I put bigger heat sinks in, so they should be able to run at a higher ampage. So on those ones, I'm running a 3 amp transformer for 2 boards with bigger heat sinks. And then I'm running a 1.6 amp transformer for the other one. And again, they've all got the bigger heat sinks. The difference in price on the heat sinks is quite a lot, actually. So I think the Tader heat sinks, the little ones that are specified on the bill of materials, they're about 50p each. They're little aluminium heat sinks, and they're about 50p each, like I say. The ones that are bigger, they're about £1.57, so about $2. So that's quite a bit more expensive, just on heat sinks. And then the other problem with the bigger heat sinks is they don't really lock onto the board very firmly, so they're prone to getting bent, which is a bit of a pain. But it's not the end of the world. It's not like you're moving it around much, is it? You know, it sits in your case and that's it. There's one there. That's a tricky one to get to. Need to be a bit more patient with these because I'm on that huge ground plane. There we go. So yeah, I guess working out the power that you need for modular is always tricky. So if you use websites like Modular Grid, that's really helpful. So Modular Grid is a website where you can kind of like mock up your dream system, I suppose, is one way of doing it. So you can pick all your modules from all the manufacturers. They're all on there pretty much. Even really obscure modules are on there. And using the software, you can drag and drop them into a case. And then at the end of that process, it tells you how much power you need. And rather shockingly, it also tells you the price, the cost of it. That can put you off. That can really put you off. You suddenly realise the amount of investment of money. But there's a couple of things with that. I think the first thing is that the price is worked out on the new shelf retail price, and you don't have to buy new modules. There's a really good second-hand used module market, so you could buy used modules. That's the first thing. And then the second thing, of course, is you can build your own modules. So you get your soldering iron and you start doing this rubbish, and then that way you save a bit of money. Depending on the kit or the parts, it depends on how much money you save. I have built a number of modules from Pusherman Productions in the UK, which is a website that sells some kits. They do sell kits now. Back in the day, I don't think there was many kits. It was mainly PCBs and panels. Now it's kits, so you can get a whole kit with all the components and everything, which is awesome. And the price difference between a kit and the built module isn't actually that much. But that's because a lot of the kits on Pusherman use surface mount components, SMD components, and the SMD components are pre-soldered to the PCB. So actually the majority of the work's actually been done for you. So that's why the price difference isn't much. But, you know, it's a few quid. And not only that, I get the pleasure of building it. So even though it's probably only about $10 to $20 difference between the built module and building it yourself, I still enjoy building it myself. You can still get some of the PCBs that are blank on Pusherman. So you're doing all the surface mount components. And surface mount, people are a bit scared of surface mount. There's nothing to be scared of, but some of those ones on Pusherman can be really small. So I actually bought a hot air soldering station for those. And as I say, I did a few, which turned out okay. They were, to be fair, if you've got a hot air soldering station, they're as easy, if not easier, than through hole, to be fair. Having said that, the very small packages of surface mount components, trying to hand solder the very small ones, I think I'd struggle with. Where Frequency Central have used some surface mount components, they've actually made the pads a bigger package size to make it easier to solder by hand. And to be fair, they're dead easy to solder by hand. So, like with Frequency Central, certainly, if there's SMD components, don't be put off, because they're not difficult. Although I did make a terrible mistake, but it was my own mistake. I didn't read the instructions properly, which is a thing, right? I had some embarrassing moments. A red face as people pointed out my error. Well, I say people. Rick from Frequency Central pointed out my error. Onto the Mickey. That's all right. We don't mind that. Mentioned last time about solder bridges. If these are bridged here, it wouldn't actually matter because the current's going through those diodes in series in a row. But we will be testing for shorts as we did before we plug anything in, because that's good practice. So there we go. We've got the diodes in. What does the build document say next? I'll have a sip of my coffee. Capacitor. Excuse me. 100 NF capacitors. Nanofarad NF. Nanofarad. Now, because I'm stupid, I have to write on these that 0.1 UF is the same as 100 NF. And if you're new to all this, this can be really confusing, but the good news is, if I go to the website, if I click on that build document and I click on the one I want, so we're 100 UF, 35 volt. Oh, that's the wrong one. Not that one. No, I've lost my build document. UF, 100 UF. 100 NF, there we go, polybox. 100 NF, polybox, there we go. So on there, 100 NF, it says 100 NF and then it says 0.1 UF. So because I get really confused because I'm dyscalculic and dyslexic, I write on the bag what it is that I need, which just saves time in the future. Really, that's the only reason. So it says NF, that's these, and these are the polybox capacitors. I used to try and pull these out of the thing, but they're really hard to get out, so I just snip them off these days. They're much easier. Now I wonder if the little cheap component tester, I wonder if it'd be able to do that. Let's see. Can we do that with the cheap thing? I think the biggest challenge with this is getting the thing located in the teeth. Yeah, there you go, look at that. And we've got 103.5 nanofarads. Perfect. Oh, we could check the other one, I suppose. Let's try the other one. Which one is it? I'm quite impressed with this cheap thing. I've had it a while. I've used it before. Well, that's 103.6 NF, so it's 0.6 nanofarads over. But that's fine. So where do these go? These are quite easy to find because they're like an oval lozenge shape. I like to put the numbers the same way around because of OCD and all that. I've got another one there. Can't really see the numbers, that's the trouble. Should put my my goggly things on. So there we go. Now I quite like to get them straight. That'd be nice. It's virtually impossible. I suppose if I splayed the legs a bit, it would help. And we could do the solder one leg and then check it and all that, but I can't be bothered really. No one sees this really. Oh, although it's for someone else, isn't it? I'm making this for someone else. It's the first time I've ever made something for somebody else. Maybe I should. Maybe. All right, let's take the time. Let's do the job. But really the important thing is that you've got a good electrical connection between the components and the printed circuit board. That's what really matters. So apply that heat and leave it on for a bit. That doesn't look great, but it's fine. Polybox capacitors, these are ones where you don't want to leave the heat on for too long because you do start to melt the polybox, which is less than ideal. So even if it's not perfect, as long as there's electrical connection, I'm just not going to go back in and do it again because I don't want to melt the polybox. So I hope this encourages my sister's boyfriend to get properly into modular, and then that can lead him to financial rack and ruin. That'd be great. Evil. Yeah, it's not that bad though, is it? Anyway, going back to modular grid. Modular grid allows you to plan out your modular unit. Now, there's a bit of a problem with that though. So that's great when you know exactly what your end goal, end instrument is. Like, okay, I want to make a 9U, so that's a 9 unit. Sorry, I should say a module is 3U. So a single module on the dope for eurorack standard is 3U. So a 9U rack would have 3, 6, 9. So it'd have 3 rows. And then if it's 104 HP, that's how wide it is. So yeah, if I wanted a 9U rack, and I wanted to do ambient stuff with a bit of techno and maybe some sound design, that's totally achievable. But how would I know as a beginner what I need to do that? It's a real minefield. So whilst it's great to say, yeah, let's plan our system and stuff, the reality is it's quite difficult because you don't know what you don't know until you buy it, try it, and decide whether it's right or not. That can be difficult. It says do the LEDs next. 1, 2, 3. Now I did have a bag with lots of different coloured LEDs, and I was going to be all like creative, and I was going to put the 5-volt LED as a different colour to the other ones, but I've lost the bag. I don't know where I've put it, so I can't do that. And if you're like me, you've probably forgotten, or you do forget, which leg of a diode is the cathode and anode, the anode being positive and the cathode being negative. I can never remember, but what I look for is on one side of it is a flat. I believe the flat is negative, so the short leg is negative, I believe. But the good news is, even if you don't know, there's a flat on the PCB. So if I put the flat of the LED against the flat of the PCB, and I will double check because I do make this mistake all the time, then I should be the right way around. So light emitting diodes are literally a diode, so the current will only flow one way through it, so they are polarity sensitive, as we said. So because they're polarity sensitive, you have to put them in the right way around. And these PCBs are great because they're very, very clearly marked. You've got that standard method of marking. So the oh, that's got a bit of plastic stuck on there. That's not going to let it sit flat on the board, is it? That bit of plastic. Low production value. Can I get that bit of plastic off? Yeah. Yeah, doing it in the standard way is quite useful, because that's how it should be. That's the right way. So just to recap, the LED there, the cathode is the flat side. On the LED itself, there is a flat side, and the flat side is the short leg. So that leg there, the short leg, that's the cathode, the negative, and then the anode, the long one, is the positive. And the other way you can tell is Rick and Frequency Central have put a square pad on the anode, so the positive has got a square pad, and I think that's standard across all the components. Should have a square pad for a positive side. So they're sitting nice and flat. Solder them on. Take my goggles off because for some reason I can't seem to talk and wear my magnifying glasses. What's that about? Why is that a thing? That shouldn't be a thing. That's not a thing. Anyway, there we go. Again, don't want to leave the heat on too long on the LEDs because we'll start to melt the plastic. They're going nice. I suppose the trace, you know, the internal wiring, these are the traces. I suppose the traces on the LEDs don't need to be as thick, so they're heating up much faster. Much faster. It's wiggling around a bit. That's bad news. I need to hold that steady. I'll take the heat away. How am I going to get in there? How am I going to do them? Just bend them back up. Yeah, so my sister's boyfriend is not confident with soldering because he hasn't really done it, and I really want him to start because it's not hard. Soldering's easy-ish. I think the difficult bit about soldering isn't soldering; it's fixing a mistake. That's a bit harder. Actually, soldering's pretty straightforward, isn't it? You know, apply heat, apply solder, don't wiggle it, done. I'll reflow that one. That's on a thicker plane. I can see the trace is much thicker there than that little trace there. So that trace has taken more to heat up. So I might go in and just reflow that. There we go, that's better. Yeah. So come on, get your soldering iron out. I'm making these videos for you. And then not only can you have the financial ruin of building a modular, you can also turn your house into an absolute tip while you do it, which is great, isn't it? Because you do end up with a lot of crap everywhere. I'm not very happy with that joint. I need to have a look at that with the magnifying glasses. Yeah, so going back to modular grid, you can plan out your system. Oh, that's okay. you can plan out your system and decide, you know, I want these modules and I'm going to have this size rack, and then you know how much power you need, and then you can buy your power supplies to match. Great, fantastic, yay! Job's a good one. But when I started, I had absolutely no idea what I wanted to do with my modular. I knew I just wanted to build some stuff and have some stuff, and I really didn't know what I wanted it to do. I kind of wanted it to do some generative stuff, so that's where you, well, I don't know how to describe generative music. That's where the machine does it. The problem with generative is you need it to have some randomness. You need it to create its own sound effectively, which is quite difficult. Now, I don't know how this works. I have no idea how you do this. I don't think I've ever tried a transistor in there. Which way around do I go? Oh, that way. So if you're going to do generative music or generative stuff, you need to plan. Oh, I keep doing it the wrong way around, don't I? You need to plan your modules that are going to work like that. You know, that are going to do that job. So my problem is I never know where I'm supposed to put this to check a transistor. It should check a transistor. Sorry, this isn't a transistor. Sorry, voltage regulator. No, see, I can't do it. It's probably because I'm putting it in the wrong slots. So what do? I do it that way and then let go. Or it's not making contact. I'm sure I've done them before where it's tested it and it's worked. Yeah, no idea. I think you have to go a different way across these bridges. Well, that's doing something, but it doesn't. No, I don't like it. Maybe it can't do a voltage regulator, but that's fine. So this component is the, what are these? 78L05. 78L05, I think, is a voltage regulator. I will just check. I'm pretty sure it's a voltage regulator. Yes, it's a plus 5 volts, 100 milliamp voltage regulator. That's the part. That's what we're doing. And these are also sensitive to positive and minus, polarity sensitive. So again, on the board, really clearly marked. The unit has a flat side. The PCB has a flat side, so it's as straightforward as that. They never quite go in straight, these, for me. I'm sure for some people they do. It says there's 3 of them. Does it say there's 3 of them? Oh no, 1 of them. Sorry, just one. Just one. Just one. And that makes sense, doesn't it? Because the one that there is for the 5 volt rail. So this is just for the 5 volt rail. It's not needed by anything else. And dear Mr. Holt, in his build instructions, suggests that you, to avoid a solder bridge on this, that you do either do the middle pin on its own, which is what I'm going to do. So we'll do the middle pin. A bit more solder on there, I think. And then wait, and then do the 2 outside pins, or vice versa. The reason being that if you heat up one of the pins and then go to the next pin, you heat that up, this has still got heat in it, and you're likely to get a solder bridge. So if you do them separately and then just wait, let it cool down, you're less likely to get a solder bridge. And it was a top tip, and luckily that top tip came early in my soldering. So thank you, Mr. Holt, because that was really, really helpful. And I didn't really know what I was doing, so I still don't know what I'm doing. Just chatting away, really, isn't it? I will do some of these live at some point, maybe. I'd like to do it when people are chatting online, but I don't know how I'd read the screen for people's comments and chat and solder. Like it would be quite difficult, I think. But I certainly enjoy watching videos like that. There's some remote control car guys that do that. Scale Builders Guild and Harley Designs. Harley Designs does a really nice video podcast, I suppose, where he builds stuff, chats, and his wife comes and reads the comments. His poor wife. Install and solder 10 UF and 100 UF, and it says observe the polarity. Now that makes sense, because now we're going to do electrolytic capacitors. These are the 10 UF and the 100 UF. Where's the 100 UF? I won't get them both out at the same time, just checking I've got them. They're the 10 UF. I haven't seemed to have got 100 UF out. I may have to search for them too. Or I did get them out and I've put them to one side because they were the wrong ones. 10 UF, let's do the 10 UF. It'll be fine. How many of these do we need? 10 UF. We need 2. So these are electrolytic capacitors, also known as cans, I think, or aluminium cans. They do have a positive and a negative, so we need to make sure we get these the right way around. And these are the 10 UF. Just going to double check that they are 10 UF. They're not in the wrong bag. They're 10 UF. I was watching another video the other day, and again, short leg cathode, long leg anode. So short leg is negative, long leg is positive, and also it's marked very clearly on these, which is the negative leg. And then on the board, just like before, the square pad is the positive, the round pad is the negative, and it's actually got a little positive sign next to it. So the positive rail, or the positive pad, is really clearly marked, which is ACE. Thank you very much, Rick. So there we go. Beautiful, easy to follow PCBs with Frequency Central. Really like them. So I'm going to double check that I've got negative, negative, bend the legs to keep it somewhat flat to the board-ish. They do wobble a bit. You can kind of bend them straight. That's fine. And then solder them. So yeah, it'd be fun to do this live, but I'd need someone to read out. I think I'd need someone to read out the comments as people chat. And then the other problem is time zones, isn't it? So like at the moment I've got 10 subscribers, but I don't know where in the world you are. So you could be somewhere where it's, 3 o'clock in the morning when I'm up and awake. And that'd be a shame, really. I'd feel like I was shortchanging people. I am committed, though, to very low production standards. You won't get any flashy cameras here and posh lighting. You'll get no groovy editing. That was a horrible solder. So let's just go and reflow that. Yeah, you're not going to get any of that from me. I ain't got time, right? I ain't got time. I literally shoot these videos on my phone. I even edit them on my phone. That's shocking, isn't it? The only thing I will do is I will try, when we're doing the actual modular and making a racket with it, I will try and record the audio from the modular and sync it to the video, because mobile phone, microphones are not brilliant, are they? They're not great. That's not fun. So there we go. Now I've lost. I've lost the other capacitors. Ugh. Or I didn't sort them out. I thought I'd plan this. I thought I'll plan this nicely, and it'll all be ready, and it'll all be dead good, and then it'll be 100 UF we're after. 100 UF 35 volt. 100 UF 35 volt. So this is my capacitor box full of crap. 100 UF 35 volt. 100, that's 10. Got them. 100 UF 35 volt. Can't read that. That's 25 volt. 100 UF. That's 1 UF. 220 UF. 47 UF. 2.2 UF. 0.47 UF. 100 volt. What am I looking for? 100 volt. 35. 47 UF. I ran out of 47 UF and I over-ordered. I got a bit confused and ordered a load. 10 UF. Got everything but 100 UF. And I'm sure I picked them out. 220 UF. 10 UF. 22 UF. Oh, this. There we go. 100 UF. In a nice blue. Again, these have come from Tader. Because of the shipping, like I said, buy them in bulk. The thing with capacitors though is if you do mess up your order and forget to get some, like, they are pretty available. You know, you can buy a few. You don't have to buy a massive box. So they're okay. I need 3 of those. There we go. So slightly bigger capacitors than the other ones. There we go. And again, clearly marked. These ones are blue cans, but again, clearly marked. You've got the negative there, short, long. And again, clearly marked on here, but the other way around. No, the same way around. Same way around. So 100 UF in there. 100 UF in there. So these are all negative going that way. Is the other one the same? Yeah, it is. So we should end up, when we lift the board up and look in a minute, we should end up with all the negatives pointing the same way, which is very helpful. There we go. Soldering iron heat up quickly. And we get these ones in. Yes, I found it really difficult when I started to plan, you know, what power did I need, because I didn't know what modules I needed. And I still don't really. I wanted a system where I could experiment. And that included trying a module, you know, buying a module, building a module, whatever, seeing if I liked it. Because I've been doing it for a while now, I kind of know the modules I like. I've definitely decided that I prefer modules where there's not a lot of menu diving. So a lot of the digital modules, there's quite a lot of menu diving. There's a few modules that I'll tolerate with the menus. Notably mutable instruments, braids. The menu system on that and the encoder is quite easy to use. And even if you're not very clever like me and you forget stuff and you can't remember what a function is and things like that, it doesn't matter because it kind of tells you on the screen. So braids is a cracker. Braids doesn't bother me at all. I like braids. And then the ornaments and crimes module, which is a bit more menu divey. I'll tolerate that one because of what it's capable of doing. The firmware on that is fantastic. There's a guy called Phaserville, DJ Phaserville. I think the YouTube channel's just Phaserville. He's amazing because he's picked up a lot of the software development for that, and it's open source. And he's got, or he's designed and developed software, probably with some other people's help as well, where you can run a firmware called Hemispheres, which gives you about 30 odd functions. Plus, you can run some of the functions as full screen. That's gone badly. There we go. And that's amazing because it just gives you the best of both worlds. When the original Ornaments and Crime software came out, the original firmware, they were full screen applets. And they were great, don't get me wrong, they're amazing. I think there's one called Quantumane and Harrington 2000 and strange names, but they're really, really good and they do some amazing stuff. And that was amazing. There was about 6 applets, I think, maybe 7, that were really powerful. And then someone developed Hemispheres. There might have been something before Hemispheres, I'm not absolutely sure, but Hemispheres was developed, and Hemispheres allowed you to run 30 odd applets, and it splits the module in 2, so you effectively get 2 channels of each of the applets, which is really good, and you can mix and match them. It's fantastic. And then Phaserville is you can have 2 or 3 full screen applets and then a bunch of the other applets, and there's also some tuning applets in there that are really good as well. So that's fantastic. It says install and solder 2K multi-turn trimmers. Now these are important because when we hook it up to power, eventually, these are going to let us, with the multimeter, these are going to let us dial in the voltages correctly so that we get 12 volts positive, 12 volts negative, and a 5 volt. So these are important. Now, I don't think it matters which way up they go. I genuinely don't. And if we look at the board, it probably doesn't really say. Here we go. This multi-drilling, this multi-hole situation is so you can use different types of trimmers. I think lately Rick's been saying use these ones because I think they're a bit more durable and a bit more accurate. So there's 3 holes across the centre, so they would go across the centre. There's nowhere else for them to go because they've got 3 pins. I'm going to look at the picture though and see which way around Rick's put them. I don't, as I say, it doesn't matter, but yeah, just in case. So Rick's got his board that way around, and then his trimmers are that way around. So we'll do the same just in case, but I genuinely don't think it makes a blind bit of difference which way round they go. So to keep them flat, I'm just bending the legs, and then he's got the other one the same way round with the screw the same way. So I'm just bending those just to keep them flat to the board, and that kind of helps just hold them in place. Yes, I had no idea what I wanted to do with Modular. It was mainly about making an instrument. It was mainly about making something that had a function and spending time doing it in an enjoyable way, more than the music. Having said that, I really enjoy patching for larks because it's good fun. Just good fun, isn't it? And I have a plan to make some videos about the actual eurorack and using it. I don't really want to do what everyone else is doing. There are some amazing YouTubers that I love and watch all the time, and I love their content. Like, I really adore it. I've been patrons for some of them for some time. I've had to stop that because I'm broke. DivKid would be notable. DivKid makes some fantastic review videos, but not only does he review the module, he shows you how to use it, which is brilliant. Because if you're stupid like me, that really it really helps. Because a lot of the modules I look at, I just go, I don't know what that does. What does that do? I don't know what that does. And then Ben DivKid very kindly kind of says, well, it does this, but if you use it like this, you can do this. And his videos are great. I can't, why do the same thing as someone like that? Because he's doing such a great job on it. So I've got no interest in doing videos that compete with my eurorack heroes. That would be bad. Don't want to do that. That's why I'm doing these long form build videos in real time, because not many people do that because it takes too long, doesn't it? It takes too long for you to watch it. It takes too long to make it. That's also why I'm doing intentionally low production value, because everyone else has got quite high production value. That makes it different, doesn't it? That makes it different. And then the other thing, I suppose, is the rambling conversation is intentional, because I quite like just chilling out and listening to rubbish while I'm doing something else. So I'm guessing there's at least one other person in the world who likes listening to rubbish and chilling out doing something else. That's my kind of hope. Done that. Install and soldering it here. Done that. Install all power headers. Now this bit will be dull. This is the bit that I'm afraid, from a TV entertainment point of view, is going to be rubbish. We've got 12 of these to put on. There's 16 pins on each one. Now other YouTubers would, of course, speed run this and show you doing it differently. So on these, I don't know whether you can see, there's a little arrow down there that says that pin is negative. And then on the PCB, we've got this big white line, so it's really obvious which is negative. So these are going to go like this. If I can get it in. There we go. They're going to go like that. Right. So that's how they're going to sit in there. And actually, Rick, because he's a superstar, he's actually even put a little mark on the board where the cutout, the notch on the boxed power headers goes. So you would be hard pressed to mess this up, but mess it up you can. Probably the easiest way to mess it up is to just forget that you just put one in the wrong way around and then solder it. That would be a pain. So we're not going to do that. We're going to do it right today. We're going to take our time. We're going to double check and triple check and things like that. So yeah, this will be perhaps the dullest moment of YouTube history on the face of the planet, because 16 pins, all of these, that's going to take a while, isn't it? That's going to be a slow process. Now you could do a thing called drag soldering, and I have done drag soldering. And drag soldering is where you change the tip on your soldering iron to like a longer, flatter plate, and you heat up more than one pin at a time, and you literally drag the solder and drag the soldering iron across the pins, and it actually goes quite quick. And as I say, I have done drag soldering, but I'm not going to do that today because I want to make sure we've got no solder bridges. That's the main reason. Now the other problem with this is I need to flip it over, and they're all going to fall out. So I need something to put over the top when I flip it over to hold them in position. Let's use that. And that means we can flip it over without them all falling out, hopefully. And we've got a problem already because that is sticking up higher on one side than the other side, which means we're going to end up with a load of wonky sockets. We don't want that. So I think we'll go for tape. Can we do tape? I think we can do tape. We'll do the tape thing. So what would help here is if I had something to raise this up a bit. And again, tape is really good for that because tape's got a big hole in the middle. I'll use this little pot instead. There we go. Let's raise that up. Pop those on. Do that all over again. So there's no Blue Peter. Here's one I made earlier, is there? It's just a laborious, long process of watching an idiot build this crap in real time. Is there a competition for like the worst YouTube channel ever? Can I win it? I think I'll be there. Got to be somewhere near, haven't I? And then what'll happen now? Because I've had to put them all back in again. I guarantee I've probably put one in the wrong way around. So I need to check. I need to double check, don't I? Calm myself down and definitely double check, triple check before we solder them. So we will take the time. We will do it right. Let's just double check. So first check, have we got the negative side down here? Yes, we have. So if I take one out, you can see the white line is there. Fantastic. Second check, notch, 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 notch. So all the notches are pointing the right way and they match with the PCB. So we know they're the right way around. I reckon we need about that much tape. What we'll probably end up doing is just soldering one pin on each leg, checking that they're flat and straight, and then soldering the rest. Let's see if we can do this with tape. This is always a fiddle, this. Oops. See? Always a fiddle. Ugh. And of course I've not made my tape long enough. But I do kind of want them to sit flat. It would annoy me if they're not. And of course every time I put the tape on, it's pulling them. Pulling them. What else could we do? Well, the other thing we could do is we could use something maybe that would step it up. That might do it. Let's do that instead. What we got? Is that long enough? No. Of course, we haven't got anything long enough. That's typical. What have I got? The problem is, you see, the capacitors are higher than that. So if I had something that just pads that out a bit, that would solve the problem and it would be easier for us to solder. I've got some foam with that. Is that long enough? It's almost long enough. Let's try that. Will that help? It'll mostly help. We've got a couple that it's not going to help. And then, of course, it's going to fall off now, isn't it? I can't. There we go. There we go. It's like some Heath Robinson thing. But all I need to do is one pin. I just need one pin on each of them. That's all I need. One pin. So I am going to put on my stupid goggles for this because they're quite small. It's quite hard to see. And I don't really want to create a problem with the solder bridge and things like that. My soldering iron has gone to sleep, which is fine. Yeah, we'll do it real time. So now the problem is with my goggles on, I can't actually see the board at all unless I put my head under the camera. So that's not going to work. So let's not do that. Let's see if we can get one pin done on all of these, and then we can check and see if they're flat. That's the game now. Dooby. Yeah, so I had a bit of a problem when I started trying to work out what I wanted, and that was okay. I kind of knew the basics of the power supply. So the way the power supply works is you've got a plus 12 rail, they call them a rail, but you've got a plus 12 side, and then a minus 12 volt side. Sorry, I should say volt. A plus, what was I saying? A plus 12 volt, a positive 12 volt side. That's horrible. And a minus 12 volt side. And then some modules, but not a lot these days, use a 5 volt supply as well. So they need a 5 volt supply. There aren't that many modules that do that now. And sometimes where a module needs 5 volts, they'll actually put a 5 volt converter or a 5 volt power transformer, regulator, voltage regulator in the actual module, which is really neat. Some power supplies just don't have a 5 volt power supply. You can also get a little plug-in thing that plugs into your bus board and then provides a 5 volt power supply. I think Dope for make one of those, for example. So you can get that, and then you can have your 5 volt power supply if that's what you need. These boards do have an inbuilt onboard 5 volt power supply, which is lovely. So you have that luxury. Yeah, so you've got minus 12, plus 12, and then you've also got a 5 volt potentially if you need it. You don't, like I say, not a lot of modules need it. I have got a few. And of course, one of these has fallen out. There we go. Of course it has. That's a thing, isn't it? That's going to happen when you try and do this on camera. There we go. So now with my special foam thing and my fingers deftly holding everything, I think I can get it somewhere near. So now we can have a look and see if they're flat. I've missed one. There we go. Have I missed one? Or is it not soldered properly? Or is it pulled out of the socket? Oh, it's pulling the pin out of the socket. That's great, isn't it? There you go. That's joyous. But with one pin in each of those, we can check that they're mostly flat. And they're kind of pulled over to one side a bit. So if I need to flatten them off a bit, if I just reheat, hold the socket, try not to touch the pin because the pin's really hot, I can just get them all settled back in because they have all pulled over to one side, as they would, of course. But it's worth taking the time in it, you know. Just making it nice. Just making it nice. I've hardly got any solder on that one. What was I thinking there? Oops. And of course I have caught the plastic with the soldering iron somehow. I've done that. It's working on the other side. That's strange. I've melted the soldering iron a bit. I must have touched one of the plugs by accident with the soldering iron. I don't know how I've done that because I was working on the other side. It's got some strain on that one. And I will go through and reflow these because they are moving around a little bit, which that's not ideal. It doesn't help that the pins seem to be loose in the box headers. So when it's sliding around, it's actually the pins that are sliding through the plastic, not, if that makes sense. I've not had that before. I don't know why. I've got a batch where they've not really got the tolerance, or I've melted the plastic too much, which is a thing that does happen. Ouch, that was hot. So what I can do now they're flat, I will put some more tape on just because they seem loose in the plastic. Yeah, so what I did with Modular Grid is I didn't do Modular Grid. I didn't use Modular Grid to plan out my system at all, really. What I did instead is I looked for a power supply that was capable with what I thought I might need, and then went from there. And when I started, I didn't plan a big case. I just planned a very small case. So it was 104 HP, and just one 3U, so just one module height. And I'm glad I did that. And that was quite a good thing to do. Partly because what it meant was when I was ready to step up and get more modules, I just bought another little wooden case, and that was it, really. It was as easy as that. And then that way my system grew with me, and all I did was just, because it was a new case, it just meant adding a new power supply to that case. Was it cheap? Yeah, it wasn't too bad. I mean, the first case I built myself, so that it's rough. It is rough. It's not pretty. Do you know what I mean? It's ugly, but I did my best. I have basic woodworking skills at best, so I built that out of plywood, and it's just a box. That's all it is, just a box. But it seems to work quite well. And then I just put a switch on it and a socket, wired it up to one of these. And that's the other reason why I've stayed with these power supplies, really, because actually they're quite organic. They can kind of grow with you, and they're also a linear power supply. And a linear power supply is supposed to be quieter, so you don't get as much interference. And to be fair, you never hear anything from these power supplies. They are silent. I have, however, had a problem with digital and analog modules, and this is not peculiar to just these bus boards. And I've done some research, and I still don't understand any of it. There's some fantastic people on Modular, which is a forum, who've given me lots of kind of information about why it happens and how to stop it, and I don't really understand like stuff. I suppose where I have understood a little bit more is I think you get a thing called crosstalk between digital and analog. It doesn't happen with every module. And the crosstalk happens, I think, because of what they call the zero reference, or we'd call it ground, but ground's not the right term for it. It is zero reference. So zero reference in this case is this trace here. Can you see that trace there? That's the zero reference trace there. So some modules basically interfere with each other on the zero reference, or the ground. I shouldn't call it ground, it's zero reference. It's not ground, because it doesn't go to ground. It doesn't go in the earth. I think the correct term is zero reference. But again, it's electricity. I don't really understand electricity. There you go. So basically, the issue is that they all share this common zero reference rail. And I believe that's where the interference happens between some of the modules. And when I had one power supply in one case, I did have that problem. It seemed to be the sample and hold module, which I don't really understand because that's analog. But anyway, the sample and hold module would cause the oscillator an analog oscillator to pulse, like you'd hear it. So every time the LED went on and off on the sample and hold module, the oscillator would kind of pulse audibly. You'd hear it. So that really annoyed me. And to be honest, it led to me not really using my analog oscillators much, which is a shame because they're amazing and they've got so much kind of richness of tone. They're quite harsh. Like if you just plug them straight into your sound card, they're really noisy. But quite like an analog oscillator. So that really annoyed me. So what I did in the new case, or the suitcase that I built, is I split the power supplies. So the analog power supply, one of these, is separate to the digital power supply. And now I've got very, very, very clean signal between the two. Right, I don't need the tape anymore because they're now properly stuck down. I'll get rid of that. And we just got to do this endless soldering. Now, because the ground planes are a bit of a pain, when I get to the ground planes, I'm going to use some flux. I say they're a bit of a pain because, as we've already established, Mr. Holt and Frequency Central have put in extra layer into this PCB. So the ground plane has got an extra layer to help with heat dissipation, I guess. I wonder if it would help with crosstalk between digital and analog modules. I'll be interested to find that out, because I imagine it would. It would be very, very interesting. We'll have a play with that. So yeah, in the new case, I don't have a problem with analog and digital. The power is enough and it's supplying the modules with more than ample power because it's split onto 2 rails and then 1 rail. That's been amazing. So I'm really, really happy. The only problem I've got with the new case is when I've put it all together, where I've put the power socket, the power inlet, they're just barrel connections. Interestingly, Dope say don't use barrel connections, and I've heard it now from a few people, and if I was going to do it again, I probably wouldn't use barrel connections because they're just not really man enough for the job. That sounded sexist, didn't it? Not person enough for the job. In other words, they wear really quickly, I think, and they go loose. And I've got one of them has gone loose, and it means really to fix it, I'm probably going to have to take everything out to get to it, because I don't think I have a socket that would work because of the wires and the wiring. I might be able to tighten it up just with some pliers, maybe. I'll try that. But other than that, new case is amazing. New case has been a revolution. I am chuffed with new case. So that's a -12 and a +12, 1 and 1. Then we've got, I think that's the 5-volt rail, and that's the ground, or is it the other way around? I can never remember. No, that's the 5-volt rail there. That's the 5-volt rail, and then these are all grounds. So that's those 3 in the centre are grounds. That's the 5-volt rail. So we'll do the 5-volt rail. We'll make sure we got that on using the same temperature and stuff. 5-volt rail should go fairly easy because it's not massively thick, is it? So if these 2 pins bridge that way, it wouldn't matter because they do the same job. There's 2 of them just because of IDC connectors. IDC connectors were never really designed to carry ampage and stuff, particularly. They were designed to carry a signal, so very, very low current. So in eurorack, they're all kind of doubled up mostly, and that just helps again with that resistance and heat build-up. Oh God, we're getting invaded by a cat again. No, you don't want to get burnt by a soldering iron. Really? Okay, I'm going to have to stop for a minute because I don't want to burn the cat. it would be bad to burn a cat. Burning cats is not a thing. So I'm going to take a break, give the cat some attention, and be back in a minute. Right, got rid of the cat. Poor cat. Not like permanently, just like put her out. Bad solder there. That one needs fixing. So sorry about the interruption. There you go. That's it's all part of the thing, isn't it? It's all part of the process. It's real life. We're doing it for reals. Yeah, so modular grid, what I did on modular grid is I kind of looked at the modules I might want, and then kind of worked out roughly what power I'd need. And then rather than specifically build an instrument, I kind of built it to do what I thought I might want in the future. Now that has led to some problems, because in an ideal world, what I'd like to do is just have a single power cable, just one power cable into the case, and then yeah, it's just one plug, isn't it? It's just one plug. That'd be better. But looking around, it's quite hard to do that. It seems like you can do it, but it costs you a lot of money. There are some amazing power supplies for eurorack. But the price for me is just too high. I can't afford it. It's as simple as that. It's not even a question of would I want that. It's a question of I just can't afford it. So there we go. I know that Constant Lab, that's Constant Lab with a K. They make a power supply that's got filtering between analog and modular. So that eliminates the kind of crosstalk. So that would be a solution. Trogatronics make some really nice power supplies. I'm quite taken with the idea of Trogatronics. I don't know whether I'm pronouncing that right. Trogatronics, I think, are in Canada. So the problem there is that actually the power supplies are quite reasonably priced, but the shipping kills it. So that gets very expensive. So I'm not sure. I might go the Trogatronics route one day if I can save up enough money. With the next case, I am planning a new case. So I have the suitcase, which is all videoed on this channel. By all means, go have a look at that. The suitcase build. I'm quite pleased with that. It's come out better than I hoped. And the reason for doing the suitcase build was so that I could take the eurorack to work. So I work with young people, and I wanted to be able to take the eurorack to work and let my learners, students, pupils, I'm not sure what the word is, but the young people I work with, let them have a go, because what could be better than having a go with the eurorack, you know? And have some fun, chucking some cables in some sockets and seeing what noises we can make. And it is fun, and we're enjoying that. It's good. I work with a young man at the moment who seems to really like it. And then we throw his guitar through the eurorack, so he gets to best of both worlds, really. He gets to play guitar. He likes playing electric guitar. And we get to mess with the sound, which is fun. So I built the suitcase so that I could safely get my eurorack system to work and back without damaging any modules. That was the main reason. And upstairs I have, which you've kind of seen a bit of, I have the home studio. I'm laughing because it's a bedroom in it, and it doesn't look like a home studio. It doesn't feel like a home studio, and it's really cramped, and there's far too much stuff in there. And at some point I'm going to redo that as well, so that it's a nicer place to create music. That room needs some work. The whole house needs work. And really, I can't do the home studio until I've done the rest of the house. So there we go. Right, so that's the 5-volt rail. So as I said, it didn't matter. It wouldn't matter if you had a short between these two pins because it's all on the same rail. Same with these two pins, but it would matter if you had a short that way. So if you had a short going that way, that would matter. The next 1, 2, 3, I think, are the ground. I can never quite remember, but I think the next 3 kind of pins are the ground. So now what I'm going to do is I'm just going to go up straight up the side and do that, more or less. I might miss one out each time so I don't get a solder bridge, just in case, because I can't quite remember. I know 3 of the 3 centre things are a 0 reference. So like these 3, I'm sure it's these 3. I say I'm sure. I'm never sure because it's electricity in it. Just need to make good solder connections. And I've locked the cat out now, so she'll start scratching the door in a minute and asking to get back in. But I really don't want to solder my cat up. I think there's a rule about soldering cats. I don't think you're supposed to solder a cat. No, I've got a bridge there. It's gone. Let's just reflow. So we go down one side and just get these going. And these are taking a bit longer to heat up, which is understandable because it's the ground rail. And I don't think these are connected to anything, these two. Yeah, no, they're heating up real quick. But these ones in the middle, they're taking a lot to heat up because they've got that extra plane of thickness in the wire in the PCB to dissipate heat. And because they're designed to dissipate heat, they're obviously taking longer to hot up. Now, I have a solder bridge there. It shouldn't really matter because I'm sure they're all ground. Oh, sorry, 0 reference. Let's call them the proper name. Don't think it matters, but just in case, I will try and clean it up if I make a mistake. It looks nicer there as well, doesn't it? Not enough solder on that one. Okay. So I think I'll not risk messing it up. I think I'll do 1, 1, 1, do 1, miss 1, that kind of thing, and then go back. I think that's the easiest way of doing it, and do the same on the other side. So Modular Grid's a really useful tool. It's free to have an account. It's a brilliant resource. It's got all the modules pretty much, I'm pretty sure, by all the manufacturers, even some really obscure ones. I built an attenuator from Pusherman years ago. It's a really good attenuator, and that's even on there. What isn't on there sometimes is the power consumption for the module. So in the case of that attenuator, it doesn't actually list the power consumption, which is a bit of a pain if you're trying to plan your power consumption for your thing. It's a shame. And that attenuator, I suppose normally an attenuator is a fairly passive thing, but that one's what they call a buffered attenuator. So it's got a little operational amplifier in the PCB, and that means that an audio rate signal is kept the same. Otherwise it will degrade over time. So if you, well, not over time, sorry. The signal will drop in voltage as you copy it. So if you've got a normal attenuator, which is just a bunch of potentiometers turning the signal down, every time you take a copy of that into another socket, it will lose a bit of voltage. Now that doesn't matter too much for control voltage, where you're using the control voltage to modulate something, but it does matter for audio, because if you're using 1 volt per octave, which is kind of the standard, as you copy that and then send it to another oscillator, you won't have 1 volt per octave then. you'll have something else, and then it'll go out of tune. It will have different tuning. So that's why that matters. Now, that means that the module, because of that little amplifier, operational amp, needs a power supply, and because it needs a power supply, it will be using some power. And modular grid doesn't have a figure for how much power it uses, and it's not the easiest thing to measure, I don't think. You can't do it while it's plugged in, because, well, you can do it while it's plugged in, but you have to unplug like the ground, because your multimeter, when you measure the ampage in circuit when it's under load, will cause a short, because the current will flow through the multimeter. So you'd have to figure out a way of unplugging one side of it, leaving the other side plugged in, so that your multimeter makes the rest of the circuit, which just isn't really the easiest thing in the world to do, is it? So I've not bothered. There you go. Just not bothered. Just not bothered. Don't know why manufacturers don't produce power supplies that are capable of more power. There must be a reason for it. Maybe you start to get interference and things. I don't know. So yes, there we go. The other power solution, and the one that I'm probably going to go with, is a Doepfer power solution. So with the case that I'm planning to build, I need 4 of these rails probably. So I'm going to go 9U of conventional normal eurorack modules, and then I'm going to put 1 row of IntelliGel sized 1U in, because there's a bunch of manufacturers now making 1U utility modules, and they look really good, and they save you a bit of, sometimes they can save you a bit of space. So your utility modules need to be accessible by all your other modules quite a lot of the time. So things like multiples, and all a multiple is a copy. It's something where you can shove a patch cable in and get a copy of your signal. That's all a multiple is. And there's 2 types. There's passive multiples, which don't have a power supply, and they're the ones where the signal kind of degrades over time. Degrades the more copies you make, in terms of the voltage starts to drop. And then there's buffered multiples, which are designed to be accurate for 1 volt per octave and audio signals. So they're something that you want to gain access to. You want all your modules to be able to use pretty much all the time. Like, they're really useful. I think when you're new to eurorack, you can't quite understand what utility modules do and what they're for. And certainly I struggle now. I still don't really fully understand what you can do with utility modules. But something like an attenuator or a mult is absolutely essential. I do use them all the time. So even though I don't particularly understand them, I've got a solder bridge there. Nasty one. Let's just heat that up. Ugh. I do this quite a lot. I do get these solder bridges on these boards. I have to stick my head under the camera now. Sorry about this. But I have got quite a bad solder bridge there. I don't think it matters. I don't think this rail particularly matters. Yeah, okay. What was I saying? Oh yeah, something like an attenuator that allows you to take a copy and then allows you to turn the signal down is absolutely useful. It allows you to control the voltage. Although they're called control voltages, CV, you have to control the amount of voltage quite a lot. So if you just plug it in, you get a right racket, really, because you might be moving, if we take a low frequency oscillator between the peak and the trough might be a difference of maybe 5 volts or 10 volts. God knows, I don't know, 5 volts. And that'll lead to quite a racket, quite a noise. So an attenuator allows you to dial that down a little bit. So maybe only get like 1 volt difference or half a volt difference. And musically, that makes a huge amount of difference. Rather than having something out of a 1960s Doctor Who episode. Oh, don't get me wrong, that's great. You get something a bit more musical and a bit more usable in music, which would be nice. So by putting those in a 1U and situating it in the rack in the right place, it means that you can take patch cables to and from it easily, like all over. So I think a 1U rail would be really, really useful. So that's why I'm going to do a case with a 1U rail. But of course that gets quite expensive, because now, you know, a set of rails is 40 quid. That's about 55 US, give or take, maybe. Well, now I need 3 plus 1, so that's 4 sets of rails. That starts to get expensive. Now I have some of them, but I don't have enough. So over the next few months, I will be saving my money if I can, and then buying maybe a set of rails every month until I've got them. So although eurorack can be expensive if you go all in, all at the start, all at once, you know, you got your power supply, you got your modules, you got your rails. That is a lot of money. Don't get me wrong. That's a load. But you can start getting the bits, like over the course of another solder bridge, over the course of a month. I've messed that right up. I need to put my goggles back on again. They are all connected, those. I can see the trace. So it doesn't matter actually that there's a solder bridge there. So yeah, if you go all in and you think, right, I'm going to build my dream system, I'm going to do it in one, I'm going to pay for it all at once. I mean, that, you know, that's definitely out of the realms of possibility for most people, I think, unless you happen to be very, very wealthy. But doing it a bit at a time, that's achievable, isn't it? You know, what's the saying? Don't eat an elephant all in one bite. That's the saying. And I think eurorack, if you view it like that and you take your time and maybe buy some second-hand modules, or you build stuff like this, it actually can be quite affordable, or at least it seems affordable, if that makes sense. Because you're not spending £5 in one hit. I think if I spent £5 on a synthesizer, I'd be quite disappointed, because I'd expect it to make me a cup of tea and everything. Like, I'd expect it to do everything, and I just don't think that exists really. It's not really out there. Like, it'll be capable of doing some stuff, but not everything. And for that kind of money, I'd want it to do everything, personally. So yeah, eurorack, you can just go slow, can't you? I suppose it's a bit like building a kit car, in a way. Like, if you built a kit car, you'd have to start with maybe the chassis. So you'd buy the chassis, or you'd build the chassis. Then you'd go get your motor, stick your engine in, do all that. I've done then. Let's go around the other side. So it ain't cheap, but it is achievable if you don't mind taking the time. yeah, time does cost money, don't get me wrong, but it's kind of relaxing, you know. This isn't particularly stressful. I'm kind of enjoying my build here. And actually, do you know what? It's really nice to build one of these for someone else. I've never done that. I've never built anything for anyone else, and there is a reason for that. It's because I'm quite ashamed of my soldering. I'm getting better though. I'm getting better. I just don't do it enough. That's the problem. Because I buy all the modules myself, I don't have the money. So most of the modules I have are built over the last kind of 6-7 years. I had a bit of a gap actually. I had a break from Eurorack, and that's quite an interesting story. So I think I mentioned before that I do suffer with some mental health issues, nothing major. A doctor diagnosed me with a thing called cyclorhythmia, because I went to see the doctor and I said, look, I get obsessed over things. I get obsessed over hobbies. And when I'm obsessed over a hobby, I have to learn everything about the hobby. I need to know as much as I can. I enjoy learning, and that's true. But it leads me to financial ruin because I spend money on hobbies, and it's money I often can't afford. And I've had all sorts of hobbies. So kite surfing, parakites, kite buggies, kayaking, canoeing, although that was a career choice. That was mainly career, but I enjoyed it. Motorbikes, archery, fencing, do a bit of Warhammer, like a bit of Warhammer. Do a bit of Warhammer, we paint some Warhammer. I don't mind admitting that on camera because I believe some of the other YouTubers that are into Modular do Warhammer. Maybe they've got the same mental health condition. So anyway, I've got all these hobbies, synthesizers being one of them, of course. And I'll go through a period of maybe 6-9 months of doing the hobby and enjoying it. And then I have to leave it alone for a bit. And when I leave it alone for a bit, I feel I can get, especially in winter, I get depressed. And it's not like real suicidal depression, but I'll have a period of maybe a month, maybe a few weeks where I just feel low. And when I feel low, I just want to hide away from everyone. I don't really want to see anyone. And my whole life's been like that. I've had periods of kind of full-on activity, you know, going really hard at something, and then just not wanting to do it and stuff. So the doctor said he thought it was a thing called cyclorhythmia, which he explained is a form of bipolar. But instead of being completely manic and suicidally depressed, it sits between that. It's not as extreme, but it's similar. I was like, oh, right, okay. That sounds like a thing. So that's what he diagnosed. And I'm not sure it's right, to be honest, because I've since found out that one of the symptoms of ADHD is exactly what I've just explained, is an obsession, a hyperfixation on a craft or a hobby or something like that, to the point where you have to do it. You're driven to do it, and then you'll not go off it, but you might not need to do it again for a bit. And then what happened in Eurorack for me was, not only did I obsess over it and need to do it like every day and learn about it and everything else, is the depression kicked in for me when I built some modules and they didn't work. Because what happens, right? You go to all that effort, you buy the stuff, you get the bill of materials, you get it all in, and you build the module, and you kind of hope it's going to work. And the last 2 modules I built about 4 years ago just didn't work. And I tried everything I could think of to fix them. I tried using my multimeter to trace any short circuits. There was no short circuits. I couldn't find any short circuits. I just tried everything, and I couldn't find them. and they weren't complex modules. One was an analog oscillator, and one was a drum voice. They weren't really difficult modules to build or anything, but I could not find the fault. Anyway, that made me quite depressed in terms of this particular hobby. And for me, it's a hobby. It's not an instrument. It's not music making as such, although that's part of it. It's kind of more hobby than that, because you build the modules, right? It's a bit like advanced Lego, really. Some of these solders are looking a bit rough. I'm going to have to go over some of them again, I think. Yeah, so I then put it away for 4 years and didn't touch it. So I've been at it for 7 years, but I haven't, because I put it away for 4 years and didn't touch it. Like, literally didn't touch it. Sat on a shelf, did nothing. Literally just sat there doing nothing. And the reason I went back to it was work, because I talked about it with this young person that I work with, or one of the young people, and he'd said, yeah, I'd like to have a go at that. And I went, oh, that's fine, I'll bring it in. Then, of course, I had to make sure it still worked, because I hadn't used it for 4 years. And it worked perfectly, to be fair, apart from these 2 modules that didn't work. And then in the process of... That's nasty. Not a nasty bridge there. In the process of making sure it worked, I was a bit like, oh, I should have a go at those 2 modules that didn't work. I should have a look and see why they didn't work. Because I should be able to figure it out. I would be able to figure that out. Surely I could figure out why they're not working. So I took my little bench power supply and I plugged the module in, and I noticed that the analog oscillator, I'd forgotten that when I plugged it in, it had gone bang. There was a puff of blue smoke, and an electrolytic capacitor blew up, which was fun. You know, it was quite exciting. Popped its top and just literally just blew up. So I was like, oh, okay. I remember that happening, and I could tell that it happened because there was the legs of the electrolytic capacitor still stuck in the circuit board, and the circuit board was covered in cardboard, because when they blow up, there's a load of cardboard in there, I think. So I cleaned it up and I replaced the capacitor. I thought, well, that's the first thing to do, is we'll replace the capacitor. And then you kind of go, well, why did that capacitor blow up? And usually a capacitor will blow up because it's received the wrong polarity of voltage, or too much voltage, too much amps all at once. So I kind of figured it was one of those two, and it was more likely that it was the polarity, because we're only dealing with a 12 volt power supply, so it's not loads and loads of power, is it? You know, so 12 volt on a 35 volt or 50 volt rated capacitor shouldn't make it go bang. So it's almost certainly that either something on the PCB was the wrong way round, or more likely is I plugged it in the wrong way round. And sure enough, I discovered the fault. And the fault was I'd plugged the eurorack power cable into my little bench supply the wrong way round. So I plugged it into the module the right way round, but I plugged it into the bench supply the wrong way round. So I had negative going to positive and positive going to negative, and sure enough, that made it go bang. So I replaced the capacitor, which isn't a very difficult job. It's quite easy. Just cut the legs off and then knock them out and with some solder and stuff, and then clean it up and then put a new capacitor in. Did that, put a new capacitor in, turned the cable round on the power supply so it was actually facing the right way. I've got another bridge there, but it won't matter because it's part of the same circuit. Yeah, did that, plugged it back in the right way round, and it worked first time. So it was a really simple thing that I'd done that had caused me annoyance for 7 years, well, 4 years. And it kind of put me off, really, if I'm honest. It put me off Modular. it put me off doing it, which is stupid. Like, why does your brain do that? But my brain did do that, and it turned me off. And I was like, well, I'm rubbish at this. I'm no good at it. I'm never going to do it again. But then the flip side is, because I put the effort into building the modules that were in the rack that worked, that's maybe why I didn't sell it and get rid of it, which I'm really pleased about. The other module, of course, when I plugged it in the right way around, just worked perfectly. It's probably got reverse polarity protection on the module, i.e., you know, there's a bit of stuff in there that stops it going bang, and then if you plug it in the right way around, it still works. A lot of digital modules are like that. In fact, some digital modules, it doesn't even matter which way around you plug them in. The ornamental crimes that I mentioned before, on the PCB, it says either way round. So I assume it could be plugged in either way round. I have plugged in other modules the wrong way around before, and they haven't gone bang. So it just depends on the module. I believe that reverse polarity protection isn't in all modules because it can affect the signal, it can affect the sound. I think analog oscillators are one of those examples where potentially it affects the sound, which is why it's not common in all of them. That ground plane really is hard to heat up. It's a big wire in there. It's a big old wire going through there, that ground plane. Taking a while to heat up, that do. Yeah, so then did all that. I hope my head's not in shot. I do apologise if it is. I can't see. I've got the wrong magnification installed in my little glasses thing, and if I'm too far away, I just can't quite see. So yeah, then it was work that got me back into it. So I was like, all right, I'll check that that it works. And then I checked it works and went, oh, I've forgotten how much I enjoyed this. Just patching cables in and seeing what noises you can get out. Ideally music, but not always. And going back to the music thing, there are other ways to create music, and I don't think Eurorack is necessarily the easiest way of creating music. Like there's other ways. So in my home studio, I have a cheap, no, sorry, not cheap. What am I saying? Cheap. I have a very old Yamaha motif rack-mounted synthesizer that I bought in 2003. So that's getting on a bit. That's quite old. But you know what? I'll get the piano. I have a nice full-size weighted key stage piano from Technics that I've had for a very long time. They don't make them anymore, which is a shame because it's absolutely superb action. And I plug that in, and I can play, and I can make music, and that's an easy way of making music. So for me, I find that the best way of making music. That Yamaha rack mount synth thing, it's got an expansion board in it, and it's got over 1,000 presets of noise sound, everything from pianos to organs to synthesizers, violins, harps, everything. And it sounds superb. It absolutely, even now, it still sounds superb. It's a beautiful sounding thing. Before I go any further, I'm just going to check to see if we've got any shorts over those power rails, because if we have, now's the time to sort it out before we put those other capacitors on, because put the other capacitors on and it'll be a bit more crowded. So I'm going to put it into continuity mode. That's one press there, and when I touch them, I get a short. So I should get a short between those two pins because they're connected, right? And I do, but I shouldn't get a short between one of those pins and one of those pins. And I don't. And the next one, 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 and the next one. So I know I haven't got a short between the -12 and anything else. Let's go, I mean, I've kind of just done it, but go the other way too, just to check. And we can also find out which are the grounds. So I think it was, yeah. So I think it's these 6 in the middle. Yeah, these 6 in the middle are the ground, or the negative volt, 0 volt, sorry, 0 volt, 0 reference volt. So you should get a short over those. So that means that one of these is the 5-volt rail. I'm not sure which one it is. It's either that one or that one. And you don't get a short there. So that's good. So they're fine. So that's really useful. It's worth checking now before you go any further. So they're great. We could also check, actually, that our soldering's good enough, because it wasn't the neatest soldering in the world. So in a perfect world, we should have continuity. We should get a beep. I'll just check the multimeter again. We should get a beep between this one and this one. And we do. And this one, and we do. 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 So we know that minus 12-volt rail is soldered correctly all the way along there. Can't get the pin in there. There we go. And then we could do the same with the positive rail. These are the two that really matter. And then obviously the zero reference. So we'll do the zero reference as well. So this is great. This is good news. This is exactly what we want. We want this continuity. And we've got it everywhere. Let's check the zero reference. And if one of the pins wasn't quite perfect, it probably won't matter on the zero reference, because you've got 6 pins carrying that signal. That's great. And I think it's that rail is the 5-volt. Yeah, it is. So that pin's the 5-volt. So we should get continuity across all of those as well. So obviously on the 5-volt, the minus 12-volt and the positive 12-volt, you've only got 2 pins carrying the signal. So it's probably worth checking those to check that they come all the way across, and they do. That's fantastic. So even though it looks a little bit not perfect, but it's okay. It's working fine. So there we go. So that's all the power headers in. That took a while. I'm sorry about that. It just does take a while. Let's see what it says next, because it's quite difficult to put in the voltage regulators with the capacitors, the big capacitors, because they kind of interfere with each other. So let's see what the build guide says. It says, okay, 2K, well, you've done them, power headers done them. Bolt LM, right, so it says do the heat sinks and the voltage regulators next. So that's fine. These are the small heat sinks that are the standard ones, if you like, in the build guide. If you wanted to run this at a higher ampage, i.e. take more amps out than 500 milliamps, you need to increase the size of these. Mr. Holt says in the instructions it's a balance between the transformer power supply amp that it can push in and then the heat sinks. So if the heat sinks are too small, it'll get hot and burn out. Now, to be fair, running it on a 1 amp wall wart transformer, I've had no issues at all with these heat sinks. And as I say, the bigger heat sinks, I haven't got one to show you, which I apologise for because they're in the case. The bigger heat sinks, they're not getting hot, so it's doing okay. So each of these regulators is rated at 1.5 volts. So I guess if you've got 2 of them, you're providing almost 3 amps of power. But you're not drawing 3 amps of power. You're drawing whatever's plugged into this. So it's what you draw that matters. And you can work that out on Modular Grid, right? So we're going to put these heat sinks on because these are the ones I've got. And that'll be fine for my sister's boyfriend. He will be able to cope with that for a while. And then if he wants to add more modules, he can obviously get another case and put another board in. He could use the same board or he could use a different board. It doesn't really matter. These don't come with a thing. That's annoying because I haven't got a thing. These are LM317s. So I'm going to leave the bag there so I know. And the reason for that is this one's an LM317 and this one is an LM337. A mistake that I have made in the past is I've done the wrong one in the wrong hole and then had to desolder it. And sadly, because these are quite chunky, they tend to pull the pads and then you have to make repairs. So rather than do that, we'll be a bit careful about where we stick it instead. We do need some nuts and bolts. So I think these are M3 nuts and bolts, and we need a couple of things that aren't in the build the bomb actually. So you need a nut and a bolt. I think M3 work. I think these, oh, maybe you don't need a bolt actually. These are tapped, so you don't need a bolt on these ones. On the bigger heat sinks, you do need a bolt and a nut. So there we go. They're M3, so that's fine. They're M3, so that's good. Now these are stainless steel. Do I want to use stainless steel? Does it matter? I'm not sure. I'm not sure. We don't need a nut though. What else have we got? Have I got any others? Yeah, I got these ones, and the difference is these are like a Phillips head, so a bit cheaper probably. The Phillips head. Of course, I need a screwdriver with that. Oh, bound not to have one. So yeah, they're M3, so that's fine. I have got a screwdriver, so I might use the Phillips head or the cross head. Phillips head, cross head. Not sure what they're called. Let's just see if that's the right size. That's too small. It'll be the one that's missing, won't it? That one's okay. So there we go. We've got a screwdriver. We've got the bolt. And then the other thing that's not in the build guide that I would recommend you get is some thermal paste. Nasty gooey stuff, gets everywhere, makes a right mess. So it's worth having something to wipe your fingers on before you start. So I'm just going to grab something. Might have to cut that bit out. Might cut that bit out. So yeah, got something to wipe my hands on. Got my thermal paste. Got my screw and my bolts. I'm kind of ready to kind of screw that all together. Obviously, the thermal paste just helps the heat dissipate into the heatsink. Now, when these sit in, they don't quite sit how you imagine. You can't put it that way up. Oh no, maybe you could actually. Yeah, you can with these. So we'll put it that way up, like that. So I'm going to put the thermal paste on the back of there. It will come out in a gloop. I'm never sure how much you need. And use this like you use as if you were putting a processor on. I'm sure the other ones I've built, I've done it like that. Let's have a quick look at the picture. Let's have a quick look at the picture. How does... Oh, you can't see. Oh, you can't see it on the picture. Can't see which way up it is. On the other ones I've built, I've done them like that. So there's a gap. I think it'll be neater if I do it like that. But will it be as thermally efficient? I'm not absolutely sure. I don't know which would be the more thermally efficient. Would it be more thermally efficient to have a gap at the back of the thing and let air around it? I don't know. It's a question. Maybe if you know the answer, maybe you could pop it in the comments. I'm sure it'll be fine if we're only dealing with 1 amp. Of course, now the screw won't go in. Typical. I always tell my students, back it off, listen for the click and then wind it in. But it's not doing that. It feels like the tap is a bit off. Because it's only aluminium, it will just drive in. Try and centre it up. Centre it up and get it tight. A little bit off centre, push it back. There we go. Now, the reason I'm only doing one at a time, yes, it would be faster to do both of them, but I've already forgotten which one this is. Now, it does say it on it, but my eyesight's really bad. I left the bag out to remind me which one it was. LM317, LM317. So this is going to go there like that. And the old technique of bending the pins to hold it in position is going to work for me. I'm going to now do the other one. So that's in situ, so I know it's the right one, and I need LM337. LM337. I suppose you should probably have a look at the numbers on it, just in case you've put the wrong thing in the bag. Yeah, LM337, so that's the right one. So same again, exactly the same again. We know we've got the right bolt size this time, so I don't need to do that bit again. So put a little bit of thermal paste on. There we go. So that's not on the bill of materials. And I don't know whether you need it, but in my head it makes sense. In my head, I'm like, well, if I want that to dissipate heat, if I put some thermal paste on it, surely that will help it transfer that heat into the heatsink, the big aluminium heatsink. I won't say big, but the aluminium heatsink. Well, that one's gone really easily. That's better. So in my head, that's the thing we should do. I don't know if it's necessary. I don't think I did it on the first one I built. I think the very first one I built, I didn't have any paste. And it didn't seem to make any difference, to be honest. Just check. LM337. So there we go. So they're in there. Now this is annoying because again I've got this gap. So let's use a bit of foam just to take up that gap. That'll make it easier to solder. And now, of course, that took so long that my soldering iron's gone to sleep. So I've only got this and the capacitors to do. So it's almost done. Quite a long build that. I didn't think it'd take that long, but then I forgot about all the power headers, which take forever. You know, that's the main bit of soldering with building bus boards, is all those power headers. Like I say, you can drag solder them, and I have drag soldered them in the past. You do need flux to drag solder. It is quicker, but you do run the risk of more solder bridges, and then unfortunately, although the actual process of soldering is quicker, you've then got to sort out the solder bridges, which is a lot slower. Now that that's in there, I don't really need to hold them in position. They should be fairly flat to the board. I'm going to do the two outside pins first of the voltage regulators, and then I'll do the two inside pins. So I'm doing them separately. So don't get a solder bridge. I really don't want a solder bridge here. This would be bad. It would be a bad short circuit. And I don't really understand quite which leg does what. You'd have to look at the spec sheet for the technical specifications for each one of them. But you have a collector and emitter. I think I can never quite remember stuff like that. Just going to trim these off now, just to make my life easier to do the middle pin, and also I can check the solder around the others. Sorry about that. There was a urgent washing machine query. Is there something wrong with the washing machine? There was nothing wrong with the washing machine. So if the edit has made the position of this board jump, I do apologise. That's why. I think that's okay. Collector, emitter, and something else. I never remember the name of the pins. You get one transistor, collector, emitter, and something else. That one's gone better. I think I might go back in and just reflow that one, just to make them look nice. prettiest, but it'll do. So again, I think you end up with zero reference collector and emitter, I think, on a voltage regulator. I'm not absolutely sure. You'd have to check the spec sheet and then it'll tell you. What's important about these when you solder these though is that you don't have a solder bridge. You could check that obviously with your multimeter, and we can do that in a minute. Although I can see that they're clear of each other, so I can actually see that there's a gap. But if you were worried and you weren't sure, you could go back to your multimeter again, put it into continuity mode, see if you've got a short across any of those, and you haven't on that one. We don't on that one. That's fine. So we know we're good. So that's that. And then all we've got left now are the capacitors. It's important to remember that we get the capacitors the right way around. These are 47,000 UF, 4,700 UF, I should say. These ones say 25 volt. Before I put them in, I'm just going to check that they should be 25 volt. Yeah, 25 volt, and there's 6 of them, the whole 6 of them. Positive leg, and you've got the negative marking on the capacitor. So we put the positive in, the negative there, and go. And this is it. This is the end of the build almost. Now the bit I'm not going to be able to film, I don't think, I will try, is joining this up to a power plug. And the reason I'm going to struggle with that is because the plug, I've only got a couple of plugs left, and it's actually in the case. So I'm going to have to join a piece of wire to another piece of wire to do it, and then heat shrink it and stuff. It's not going to be the neatest. I could take the power supply, the plug, out of the case and do that, but it is wired to a switch, so that'll mean having to rewire everything, so the switch and the power supply, and I just don't want to do it. So I'm probably not going to show you that bit, which I apologise for. What I will do is show you testing it when I've got it in. So we need to test it. This isn't enough to test it. I think what I'm going to do, I'm going to break that off, use that under there. That's just perfect. I will show you it turned on and being tested at some point, but I think with this one I'm going to have to pop it into the power supply because I've run out of barrel connectors, and obviously the transformer will need to plug into a barrel connector. And on the build guide, I think he mentions a transformer that's center positive. So the center of the barrel connector is the positive, with negative on the outside. And I had enough of those sockets, but I've used them all. I've used all of them. That's not good enough. Let's go back in on that one. Better. So that bit of the video will probably not be filmed, just because I don't think I can fit the case under the camera. It's only a small case, but and also I think all you'll get is a shot of the back of my head, because I'm going to have to lean over it to do it. I don't think you'll be able to see, so I apologise for that in advance, but I will bring you back on camera to see if we get our correct voltages and stuff. And ideally it would be nice not to have to put it in the case to do that, because it's going to be a bit of a fiddle. If you can check your voltages and your shorts and stuff outside the case with the power supply, that's much easier, just because it's easier to access those trimmers. So if you remember those two little trimmers, we need to get the voltages as close to 12 volts and 5 volts as we can using those trimmers. In fact, I don't think the 5 volt rail needs the trimmer. It's just the positive and minus. So one of the trimmers does the positive 12 volt, the other trimmer does the negative 12 volt, if my memory is correct. So So that's that really. So that's struggling to get heat in, so I'll give that a clean. Sometimes that can help. And that didn't look like a good solder. So I think it's this extra ground plane that Frequency Centre have put in. Means it takes a bit longer to heat up. Okay, that's better. I'll go back in again just because the leg moved when I took the soldering iron away. In a cold joint. Right, so there we go. That is, I think, finished. Before we plug it in, or before I do the other bit off camera, I do need to check for shorts because I've done a bit more soldering, haven't I? So we'll check it for shorts on the main inlet for it. And the build guide does say you can put a centre tapped transformer in, but that requires doing some stuff with mains electricity. For me, I don't want that risk. It's easier and safer to use the wall warts, even though those wall warts, as we've said, may not be rated quite right. They'll be close enough generally, but it's something to be conscious of. If you know what you're doing with mains electricity, by all means, knock yourself out. It asks for a centre tapped transformer, 12 volt obviously. You can run 15 volt if you're doing 5U modular. So if you're one of those people that's got a space in the house for 5U instead of eurorack, lucky you for starters, and you can generate 15 volts out of this. So you just change the potentiometers in it. You just adjust them. I presume you have to use a 15 volt wall wart, I guess, but other than that, I'm just going to tidy up these solders because looking from a different angle, they don't look great. So this one in particular has got gaps. Cool. And then the other thing we'll do before we kind of pack it all away is we give it a good visual inspection. So if you've got a magnifying glass of some description, stick it on and look for mistakes. There's a mistake there. I can see one straight away. Not a mistake. It's not a mistake. That's unfair. It's not a mistake. It's just that the solder hasn't flowed all the way around that onto the pad. How's on that one? There's a couple of messy looking solders, but another one there where it hasn't quite flowed, or it's got a little hole in there, a little bubble. Just reflow it. Bit of heat. And we got on very nicely with the solder joint. It's always worth just visually checking along, and then where you need to, just reflowing. Making sure they're shiny and covering all of the pin and all of the pad. Another one there that's not very pretty. Sorry if my head's in the way. I'm trying to see. Another one there. Especially where there's lots and lots of solders like those headers. Oops. There we go. It's very easy to miss a bit or get a bit of a manky looking joint. Very easy, far too easy. So by going back through the board, just double, triple checking visually, you can solve a lot of problems before they even arise. Also got a bit of solder there. There we go. So that is done. That is completely finished, I think. We will just flip it over and have a look at the other side. Turn the soldering iron right down. So there we go. There we go. We've got a nice, fairly neat. I've got one box header that's lifted a little bit, but the rest of them are absolutely flat. It's only lifted slightly. It's annoying though, isn't it? Yeah, there we go. So what we need to do is just check for shorts. This is the inputs. If you're running it on a wall wart transformer, you use AC1 and ground. So you have one wire going to there, one wire going to there. If you're using a center tap transformer, you'll have one of the leads there, and the ground there. I'm not using a center tap transformer. I've told my sister's partner to go and get a wall wart. He will have to buy that because I need mine. And we've got no short between there and there at all. That's great. No short there. We should get a short there, and we should get a short there, but we haven't got it across the other ones. So that is safe to plug in, which is great news. So that is the Frequency Central Routemaster, all finished up. To make this work, all you need to do is wire this bit and mount it, and away you go. I'm going to do that off camera just because it's going to be a real fight, I think, to film it, and I'll show you it when I'm done. The other thing you need to do, once you've plugged it in and got power, you just need to adjust these screws here using your multimeter. You need to adjust the screws until you get minus 12 volt minus 12 volt there and plus 12 volt there, and you just have to turn the screw until you get that reading. That's it. You'll know if it's working properly when you plug it in because the LEDs will light up, which is always a nice moment when you see those. And there we go. That's the build bit over. We'll test it in a minute. So there was a bit of good news, is that I forgot that the case that I'm going to give away, the back actually comes out. So I can show you the last bit. And the last bit's just wiring it up, really. Simple as that. So, a bit out of breath, so I was running up and downstairs. So all we need to do is strip some insulation off, because I've already wired the barrel connector. You've just got a positive and minus. You've only got two leads on the wall wart. So there's just a positive and a minus. There's nothing else. So this is the positive. And of course, in traditional fashion, doesn't look like it's going to reach. You're going to have to add a bit of cable on there. The negative on the other end is too long. So typical, isn't it? Typical. So there we go. That's a weird situation to have. But there we go. We'll sort that out in a minute. So I will sort this out, as they say. I have to scrub around in my box for bits and bobs. Some more wire. Don't know whether I've got any more of that wire. Should be a pain, wouldn't it? So if you're joining wires, you need, I've not covered this in the other way, you need to tin them. You just need to put a layer of solder on there, a layer of solder on there before you connect them up. This is the ground. It says in the manual that you can use the other hole for cable relief, but actually this isn't going to have any stress on it, so I'm not going to bother. I'm just going to bend that down into the hole and solder it. Simple as that, really. If you were doing something else, you might poke it up through one hole and down through the other. That's what I used to do. That's what I've done before. But as I say, I don't really think it's necessary in this case because it's mounted to the backboard, so it can't really go anywhere. So cable relief isn't really a problem. And this is mounted probably quite badly, by the way. It's mounted with wood screws because it's going into wood, right? So that's why it's mounted with wood screws. Oh, what have I just done? I don't know why I just did that. That was stupid. Didn't need to do that. Didn't need to do that, did I? Because I was going to bend it through the hole. That's what I was going to do. I'll pop it in the hole. I'll pop it in the hole instead. There we go. Obviously we want to join the metal, not the insulation, so that's important. That's all good. And then we need to find something just to extend this bit of wire because, oh, there you go. We'll replace the bit of wire. It's just fallen off the other end. So that's interesting. Let's see if we can go and find something else for that. Here we go. Got a load of it. So that wasn't very good, was it? That wasn't brilliant. So that's the switch. So you've got a positive connection there to the positive connection there. And then this positive connection comes out to there. So when you flick the switch, it makes a connection between these two and lets it run. So it's a really simple bit of wiring. Even I can understand that, whereas I normally get really confused with switches. I don't know why they're confusing. You only need two connections for this. If you had a DC power supply, the wall will probably have a ground, so then you'd need 3 connections because you'd have a ground, a proper ground, an earth, for safety. But this, you don't need it. You've only got 2. So your zero reference is fairly irrelevant. It becomes more relevant if you're going to link up more boards. So if you wanted to wire more of these boards on one supply, then it becomes more relevant. You would need a common 0 volt reference somewhere. Let's use a bit of blue tack. It's not chewing gum, it is blue tack, or museum tack in the States. Just tin that. And tin the other end. Oops. Probably made that end too long. Probably don't need it that long. I don't want bits of cable stuck out, do we? Try and tin that. I can't really see around there because of the camera angle and stuff. Of course, the difficulty would be holding it in position while I do it. There is a hole in those, but I'm probably not going to manage to get it through the hole. That's probably not a thing that's going to happen. And ideally, what I could do with is some heat shrink. And I had some, and I don't know where it is now. I had loads of stuff. I have a little box of it. So I'll just go and try and find that. I suppose it should be red really, but yellow seems like a live colour. I'm making a video.
Oh. I don't know.
That's why I said like that before.
Oh.
That's me, so I can edit it. Get rid of that bit. Oh dear. So, bit of yellow heat shrink. Now the problem I always have with this is when you heat up the wire to solder it, you end up shrinking the heat shrink, which is annoying at best. So I'm going to get that like that. I need to hold it in place. Let's try some tape. This is always the disaster that I have. This is where I struggle, is trying to get something like this organised before you solder it. Once you solder it, it's stuck in, isn't it? Although the other piece wasn't very well connected, so that wasn't ideal. And of course, because it's on film, I can't get the end of the tape. Let's try a bit of tape. See if we can do it with tape. I don't think it will work, but we'll try. Maybe. Yeah, there we go. Now this is a really bad angle for me, so I'm not sure this is going to work perfectly because I can't actually see anything. So apologies for that. Big old glob of solder. Yeah, it feels fixed. Stick a bit of heat shrink around the end. It's not going to go quite over it, of course, because I've now put a big blob of solder, but it'll be enough. Just to give it a bit of protection in it. Don't need heat shrink at the other end particularly, but I will trim it off just a little bit. It's a bit long. Just so we can poke it through that hole again. There we go. And then we'll feed some solder into that if I can. Again, I want to be able to see the metal ideally. Try and get the heat into both parts. And there we go. So hopefully we've got good connections there. This is solid core wire, so it will push down out of the way, which is quite nice. So that's now ready to test. So the other bit that you need, and there's a bit of foam under here by the way, just because there's a switch sticking out the back. So the foam's just there just to stop the switch banging on the ground. The other bit you need is one of these. So this is an AC wall wart, they're called wall warts often. This one's 1.6, 1.6 amps. So 1,600 milliamps, a little bit over what's recommended. 230 to 240 volts, 50 kilohertz, and it's stepping down to 12 volts. So there we go. These cost about £10, give or take, and they are quite difficult to find because they're AC. As I mentioned before, these are AC. You cannot use an AC DC. You must use AC. And then I guess this is the moment of truth. Before I plug it in, I will just check continuity again because I don't really want it to go bang, and I have done some more soldering. So again, we'll go between the ground and the positive. We haven't got a short circuit, so that's a good sign, which means we can plug it in. And we should get some lights. We've got 2 lights, but not a third one. That's not great. So probably what's happened is I put the LED in the wrong way around. 9 times out of 10, that will be why. So I'll bet you that's what I've done. Put the LED in the wrong way around. And this is the LED that had that weird bit of plastic on it. I wonder whether the plastic stopped the solder joint. It's not the wrong way around. The other reason is it could be a damaged LED. So what I'll do, before I worry and panic, there's no smoke, there's no smell. So it's probably okay, and it's probably just the LED. So what we can do is we can find out if we've got continuity and all the rest of it, and if we've got the right voltage. So that'll be the best way to tell. So I'm going to put it into my voltmeter mode. I'm going to go to the ground, try not to short circuit anything. So that's my ground. And I'm going to go to the minus rail, and I've got minus 13.4, so minus 13.04. So that's really good, that's really close. On the positive rail, I've got nothing. That's not good. 5 volt rail is good. So the 5 volt rail LED that's not lining up. Oh no, it's the. Why have I got anything there? So that's really odd. There's a 1K resistor missing. I've just noticed. Look at that. Look, I've missed a resistor. How stupid am I? So really obvious when you see it like that, right? There it is, 1K resistor. So I miscounted my parts. I didn't check properly. I checked the back, didn't check the front, and I've made a terrible error that has come back to bite me on the bum. But it's not the end of the world. Luckily, because the back of this board does just kind of screw and unscrew, I can whip it out, and we can solve that fault really easily. What an idiot. There you go. I said in the previous video, I always make a mistake. In the last video, I made a classic mistake. What did I do? I forgot. In the last video, I forgot to put the op amp into the circuit. That was an easy fix though, because that was just plugging in an integrated circuit board, wasn't it? Well, that's all that was. On this video, I've completely missed out a 1 kilo ohm resistor, which is why the LED isn't lighting up as well, of course, because the resistor's there, so it doesn't blow up. I may have blown up the LED. In fact, I think that's all this resistor is, so I don't understand why the 12 volt rail's not working without it, because I thought this is all it was. So we'll see, we'll see, we'll see. Now, of course, to get that flat on the board, I'm just going to have to bend the legs. Right, let's put the let's put the 1K resistor in that we forgot. See how easy it is to make a mistake. Ah, what an idiot. There we go. So let's put the 1K resistor in and see if we get a different result. I suppose the other side of this is it's good to see people's mistakes, because I think some people just edit them out, you know. But the reality is mistakes happen. It's not the mistake that matters. It's solving the problem that matters. And just, you know, that was just a visual check. And just a visual check, we found a mistake. Say we. I keep saying we. I don't know why I say we. I think it's just an English language thing. I don't mean it to sound weird or patronising or anything like that. I noticed I did it in the other video loads. Right, there we go. So let's see. Got no metal stuff under there, have I? Let's see what happens now. Hey, there we go. We got the light on now. Obvious, really. I don't want to test it while it's flapping about, because if I slip, I could cause a short circuit, and I don't want to do that. So I'm going to whack the screws back in. These screws, by the way, they are wood screws and they are oversized for the board. That's not good, really. Honestly, it's not ideal. I've used these to insulate the back of it. That's why they're there. So they're not ideal, these screws. They kind of almost, I suppose what I should do is drill the board out to fit the screw. I've done that before. It's not a problem. But I'm excited to get this finished. So I've not done that, which is bad really, because you run the risk of splitting the PCB, which would be bad. That would be bad, because that's a shame, isn't it? That'd ruin it. So those two holes are about, I can't see. There's one hole, there's the other hole. So that kind of locates it like that. So we just drive them in a little bit, just a little bit, just to locate it. I'll put the other one in, slip that one in under there. Yeah, the only reason I'm mounting it again is just because I don't want to slip with the multimeter while I'm checking the connections, because then I could cause a short circuit, couldn't I? And that would be bad. So this is a bit ugly mounting. It's not the right way to mount it at all, but it does kind of work. And the case that I'm giving away is home built, you know, it's DIY. It's all very DIY. It's all very, you know, in the moment DIY. So what we're looking for is 12 volt positive on that positive rail. And last time I didn't get that. I got something different. So I'm going to go for my ground there. Hopefully that's making contact. And we've got something very wrong. Still not right. What on earth is going on here? What have we got on the minus rail? 1305. And what have we got on the 5 volt rail? Sorry, that's the 5 volt rail. This is a bit of a worry. So it's not putting out anywhere near the voltage it should be. I'm sure it is the top rail. That's that's the positive rail there, dickhead. I've done this before and it's confused me before because I always think that the positive rail is the top most line of pins, and it ain't. It ain't. That's where I keep going wrong. Do you know, I've ruined a whole power supply doing this because I thought that. So we're at 11.39, so we're close. 11.39. Let's go up just a half turn. So we should be somewhere near now. 1, 2, 3, 4. It's the fourth rail. Oh, so close. Let's go up a whole turn, I think. Let's go a whole turn. There we go. Whole turn. 1, 2, 3, 4. It's that rail. What an idiot. Oh, I'm so close. So we go a half turn now, I think, on the potentiometer. So there was me thinking, do you know what? I think I've got another power supply here sat next to me that I thought I'd blown up. And now I've realised my mistake. I don't think I have blown it up. I've just been putting the multimeter 1, 2, 3, 4 on the wrong rail. There we go. We're close enough. So we've got 12 volts positive there. 12 volts negative there. Just ever so like 0.04 or 0.05 of a milliamp over. Perfect. And then we should have a 5 volt rail there. And we don't get to adjust that, but it's really close. Look at that, 5.021. So we're there. We've got a fully working power supply. If you bought the parts just the parts to build one, it would cost you 50 quid. But my advice is buy more of all these parts than you need, because it's so much cheaper and easier to order 40 of these and 60 of them or whatever it is than one by one. As we've mentioned, you can get the does the switch work? That's the other question. You can get the power headers if you're in the UK from Switch UK. Switch Electronics, they are. They've got them in stock. Yeah, the switch works. They're all going out. I'm going to pull the cable out. I'm just going to tidy up that last little bit of solder because it's just annoying me because it looks messy. So for less than £50, if you buy enough components, you've got a really good power supply. And they are a really good power supply. It's a linear power supply. Normally pay a lot more for a linear power supply. I mentioned Constant Lab. I've mentioned what else did I mention? Constant Lab, Trogotronics. They're lovely power supplies. They're capable of delivering more power and doing it on one lead, as opposed to having to split power supplies into different power solutions. There's also Hamilton. Now Hamilton is probably the most expensive one, but it's also apparently the best in terms of no crosstalk and zero cross reference. But it's a very different system. Instead of using these boxed headers, it uses a rail tapped and bolted to make the power rails, which is beautiful and fantastic. But if you buy those rails, it's probably going to end up quite expensive. But they've got a very, very beautiful power solution, a linear power supply. There's a company called L-1. They make a nice power supply. Mungo Electronics make a nice one. Topper Brillo. So there's lots and lots of power solutions out there for bigger racks and things like that. And of course, there's things off the shelf. So Uzus Power is one of them, and there's probably like IntelliGel have got a box with a case with power. So there are other options, but I'm broke, so I tend to build my power supply. So this is the bit that I think puts people off getting into eurorack, having a power supply that works. But actually, the frequency central ones are great. They're relatively inexpensive. You can build them relatively cheaply. You just need your wall wart. Just remember it's an AC wall wart. Don't get an AC/DC wall wart, and you're away. You can't plug in your cables the wrong way around because you've got your boxed headers, which is great. You've got a 5 volt power supply if you need it. You've got a 12 volt positive, minus 12 volt, and you can see how accurate it is. it just sits there. It's linear. So it's a beautiful, beautiful power supply. I really, really like them. I think they are great bang for the buck. There are lots of other supplies out there. We mentioned a few of them. Doepfer, of course, with PSU3, which is probably what I'm going to do for my next case. I might go with the Doepfer PSU3. It's not a bad price. So the transformer bit is about £130 in the UK. So that's about $140, I guess, in the States. And then you can make passive buses. This is a powered bus, but you can make passive buses for about £15, £20 maybe each. So that might be a different way to go. I'm going to have a look at that and consider it. Or I might stay with the good old frequency Central Routemasters. This is now revision 3. So revision 3 is green. There you go. Revision 2, I think, is the other one I had, which is red. They're identical in every way. I've been trying to fix this one, which I've realised my mistake is not that there's anything wrong with it. My mistake is I've been putting the probes on the wrong pin for the plus 12 rail. So I've ruined a perfectly good PCB there for no reason. So there you go. That's it. Hope you enjoyed the video. If you want to give a like, please do. If you subscribe, even better. But I'm not asking anyone to do any of that rubbish, because every time you watch a YouTube video, somebody asks you to like and subscribe. I don't have a Patreon. I don't have a buy you a coffee. I have a job. I have a normal job. So you know, this isn't my job. It's just for fun. But I do hope you enjoyed the video. There is some new stuff coming next week. I'm going to go away from the build videos a little bit, partly because I've run out of stuff to build and I can't afford to buy any more. It's Christmas. But also I've got a bit of a plan for a series of videos on kind of how the modular works and the bits to do. But again, like I said, there are better videos from other people with higher production costs and values. Sorry, production values, you know, people who do it properly, full time, as a career. Go check them out. I've mentioned a few of them in this video, and in future videos I will be putting some links into those channels as well, because they're all really good people. Enjoy your modular, enjoy making noises. Even if you're not got a modular, enjoy your digital audio, enjoy creating songs, enjoy playing instruments, whatever it is. And peace be with you. Take care.